4D, distributive property. So the distributive property, sometimes referred to as the distributive property of multiplication over addition or subtraction, means that you can take a number or something multiplied by a grouping of addition or subtraction, and you can spread it out and multiply it by each thing inside of that grouping. I know that's a lot of words, and words are usually the worst way for people to understand mathematics. Visual is really the way to go. What it's saying is, if I have 3 times 2 plus 5, the distributive property of multiplication over addition says that I can take this 3 that I'm multiplying all this by, and I can multiply by each of these things individually. So I can do 3 times 2 plus 3 times 5. I can distribute it through. This is getting added to that, and I can say, okay, well, instead of 3 times 7, I'll do 3 times 2 plus 3 times 5. 3 times 2 is 6, 3 times 5 is 15, gives us 21, which is what we got by saying 7 times 3, 21. And I know you're looking at this particular example going, why would I want to do that? It was easier for me to go 7 times 3. The main reason you want to deal with the distributive property is because it will simplify things when you get into algebra and when you're dealing with letters in there. But another reason you may do that is this. 7 times 142. And I know you're looking at this going, wait, Mr. Davis, there's nothing to distribute this through. That's just 2 numbers being multiplied together. We've done that many times before. But what we've really done when we do this is we distribute through. We're really saying that that's 7 times 100 plus 7 times 4 plus 40 plus 7 times 2. Isn't that really what we do when we go 7 times 142? Aren't we saying 7 times 2 and then 7 times 40 and then 7 times 1? And then we're adding them as we go. 7 times 2 is 14. So we put 1 up here. We go 7 times 40 is 4 is 28, plus that 1 is 29. And then 7 times 1 is 7, plus 2 is 9. 994. That's really what we're doing. 7 times 100 is 700. 7 times 40 is 280. 7 times 2 is 2. Oh, sorry, it's 14. Thank you. 14. Add them up, and amazingly enough, we get 994. So you've been using the distributive property. That's how we multiply. So is it useful? Sure it is. Was it really useful in this situation? No, I think it made it more work. But remember, when you're dealing with mathematics, and when you're learning mathematics, you're generally taught things on a very simple level, meaning that you are covering very simple practice items to get to a concept that can be used in much more powerful ways. And many times we look at that and go, but I can do that without that. That's too, you're making it harder. You're putting in extra work. That's true, but when you get to bigger things, then you need to have that basic method in place. So that's what it's really aiming at. So So distributive property of multiplication over addition. We can do the same thing with subtraction. If I have 3 times 7 minus 2, obviously 7 minus 2 is 5, 5 times 3 is 15. So we know what the answer is going to be, 15. So let me go below it and do the distributive property. So 3 times 7 minus 3 times 2. But it's a good example of showing us that it actually works. 3 times 7 is 21. 3 times 2 is 6. 21 minus 6 is 15. So it does show that it works. So be it addition or subtraction, and we can even complicate this even more and make it the distributive property of addition and subtraction. 5 times 7 minus 2 plus 3 equals. So it doesn't matter how much I have in here, as long as it's all combined by addition or subtraction, that I can distribute through. In fact, I'm going to change this a little bit just because I can. And I want you to have seen it like this. Remember, if you have something set right next to a set of parentheses, that means multiply. So 5 times 7 minus 2 plus 3. So I just wanted you to remember that. So 5 times 7 minus 5 times 2 plus 5 times 3. Remember, order of operations says multiply first, then do a subtraction and addition, working from left to right. So we have 35 minus 10 plus 15. And I can even pull in the commutative property of addition here and say, hey, if I've got a plus 15 here, I can pull that over here and say 35 plus 15 is 50. Minus 10 gives us 40. But also look at what we could have done here. I wrote it out, but couldn't I have just as easily gone, hey, 5 times 7 is 35, minus 5 times 2 is 10, plus 5 times 3 is 15, and have gone from this step to this step without writing that intermediate step? I know you look at these things and you go, gee, why are you wasting time writing all this? That's making it so long. That's for demonstration purposes. In reality, I would go through and I would just go 5 times 7, 35, 5 times negative 2, negative 10, 5 times 3, 15, and then I could do my, okay, that's 50 minus 10 is 40. And it allows me to go through it faster. Well, let's take a quick side look at what would happen if we were dealing with algebra. What if I had 5 times 3x squared plus 4x minus 7 in algebra? Well, now it's like, gee, I've got those darn x's in there. What does that mean? Well, it's algebra. It means there's letters in there. They stand for something. But I can do the same thing of, okay, 5 times 3x squared is 15x squared. 5 times 4x is 20x. 5 times negative 7 is negative 35. And I just distributed through. And that's where this becomes most powerful, is when we start dealing with stuff like that. But realize we could even go further into this and say, well, what we've been multiplying by at this point are single digits or single terms. But what if I had something like this? 3 minus 7 times 4 plus, we'll actually make it minus 5 plus 2. Now again, yes, I know you could do the subtraction, you do these, and then you just multiply them through. But that's not the purpose of learning the distributive property. So what happens here? Well, now I've got this two-term thing, 3 minus 7, that I'm multiplying through here. And that doesn't work so easily. So how can I deal with that? Well, another method we can use is we can build a table. I have 2 terms and I have 3 terms, right? I have 3 things separated by an operator, and I have 2 things separated by an operator and 3 things separated by an operator. So I'm going to create a table that's 2 by 3, right? 3 across, 2 down, and I'm just going to take these and put it here. 3 minus 7. 4 minus 5. 2, right? Positive 4, negative. If I just look at that, I've got positive 4, I got negative 5, I got positive 2. So now what I can do is I can just multiply each of these parts of the grid. So 3 times 4 is 12. 3 times negative 5 is negative 15. 3 times 2 is 6. Negative 7 times 4 is negative 28. Negative 7 times negative 5 is 35. Negative 7 times 2 is negative 14. And then I can just add all those things together. So 12 plus negative 15 gives me negative 3. Plus 6 gives me positive 3. Minus 28 gives me negative 25, plus 35 gives me positive 10, minus 14 gives me negative 4. So I get negative 4 as my result. Let's see if that works out right. 3 minus 7 is negative 4. 4 minus 5 is negative 1. Negative 1 plus 2 is positive 1. Negative 4 times 1 is negative 4. So it did get me to that position. Again, I would look at this and go, well, why would I want to do this when I can just do this? Wasn't that much easier, Mr. Davis? Yes, it was, but it come back to the application in algebra. And this is really why you deal with it, is because of algebra. X minus 2 times 4x squared minus x plus 3. Well, now I'm going to build my table. I've got x and minus 2. I have 4x squared minus x and 3. X times 4x squared gives me 4x cubed. X times negative x gives me negative x squared. X times 3 gives me 3x. Negative 2 times 4x squared gives me negative 8x squared. Negative 2 times negative x gives me 2x. Negative 2 times 3 gives me negative 6. And you may be looking at this going, Mr. Davis, where are you getting this from? How are you getting 4x cubed? Well, I'm multiplying x times 4x squared. Okay, Mr. Davis, that doesn't tell me anything. Well, commutative property or associative property, depending on what we're doing, but commutative property, well, it says basically that's x times 4 times x squared. Okay, commutative property allows me to say that's x times x squared times 4. Okay. Well, what's x squared? That's x times x. So I have x times x times x times 4. If I have x times x times x, that's x cubed. So x cubed times 4, and commutative property allows me to make that 4x cubed. So that's what's happening there. And yes, there's an x in there, there's a letter. But did it change the process? No. It's still the same thing, but that's what we're doing here. And now I can come up with my final result of this product. So I have 4x cubed. I have minus 8x squared minus x squared, so that's minus 9x squared. I have 2x plus 3x gives me 5x minus 6. So the application in algebra. Now remember, this is an arithmetic class, but the focus isn't just arithmetic, but it's to get you into the basics that you need to be able to do slightly higher level math, which means you need to be able to deal with variables. And variables are algebra. So let's do one final thing here and say, okay, can we determine whether we are seeing the commutative property, the associative property, or the distributive property? Can we recognize which one's in use? So if I go 6 times 2 plus 3 is equal to 6 times 2 plus 6 times 3, is that the commutative property, the associative property, or the distributive property? Well, I've got multiplication that's being distributed through the addition. That's a distributive property. What if I have 2 times 6 times 1 is equal to 2 times 6 times 1? Well, now what I did was I changed my grouping, so that must be the associative property. Well, what if I have 5 times 1 times 7 is equal to 1 times 7 times 5? Now this one may throw you off for a second, because what happened? My parentheses moved, which usually is associative because I changed the grouping. But you'll notice that I didn't change the grouping here. 1 times 7 is still in parentheses. 1 times 7 is still in parentheses, which is then multiplied by 5. So really, this is the commutative property. I took this grouping and I just moved it to the other side of the 5. So even though I had parentheses in there, it's not associative, that's the commutative property. So distributive property, associative property, commutative property.